Thank you, John, and thank you very much to all the organizers for putting this meeting together. It's been fantastic. And yeah, today I want to talk about the scientific funding process and about some of the things that perhaps we could improve there. This is all work that I've done in collaboration with Kevin Gross. Kevin's sitting in the middle in the back, hoping I can't see him in the blinding light, but he's right there. You should talk to him about all of this if you think any of it's wrong. Before I start talking about grants, I want to sort of give you the overview of how Kevin and I and our ongoing collaboration, and some of my other collaborators, I think it may fall under a scheme of something like this, like to think about what it is when we do metascience. The way I think about it, I have this kind of working model of the scientific process. What's going on? How is it that that our scientific enterprise influences what we know? And so we start out by thinking about the way that norms and institutions, and these may be brick and mortar institutions like the NIH, or they could be norms such as the priority rule for credit for when you publish, something like that. They create incentives for people to acquire money, acquire prestige, acquire various things that people like. Scientists, of course, are not, to use Jacob's term borrowed from Kitcher, scientists are not epistemically pure, they're epistemically sullied, and therefore they respond to incentives. And they respond to these incentives, in particular, in selecting research strategies. So the norms are influencing, and the institutions are influencing the research strategies that get chosen. Of course, research strategies as a first proxy are sort of used to interrogate nature, and that generates knowledge. And so through this chain, we end up going from our norms and institutions, which have evolved more or less in a haphazard way out of a system of scientific communication and inquiry in Western Europe and so on, directly linking up in a direct chain to what we believe about the world, what we don't know about the world, what we believe to be true that isn't true, et cetera. And so it's working within this framework that Kevin and I have been doing. This summer, we've spent a lot of time thinking about the way that these institutions, the way incentives generate research strategies and knowledge. What I'm going to talk about today is more up here. I'm going to talk just about some of the inefficiencies in the incentives that get put in place and the ways that scientists respond to them. So this is the kind of dismal plot that you can put up for more or less any area of the sciences. Back in the 60s and 70s, you had fairly high pay lines. The fraction of the applicants who actually receive money for grant applications. This is NIH R01s. These are the big National Institute of Health grants that would be sort of the bread and butter of a biomedical research lab. And then they start tailing off, and they continue to tail off. And they end up remarkably high. These actually are remarkably high because before you can even submit one of these, you have to actually have gone through several prior steps. If we look in some fields, say, in my home discipline of ecology and evolutionary biology, pay lines tend to be between about 4 and about 10%. So they're funding between 4 and 10% of the grant applications that people put in. And obviously it takes an enormous amount of time to write one of these long grants. So what ends up happening is that faculty effort toward writing grants at the major research universities, faculty spend about 1/10 of their total time and about 20% of their research time writing grants in the biosciences. In the medical schools, where people are on soft money and are required to raise a good portion of their salary, they spend up to 50% of their total time. Their time is almost all research, so unless they're doing clinical work or something, but they're spending up to 50% of their total time writing grants to keep that grant stream running. And so, we have a system where we've got all of this, all this stress, all this effort, all the uncertainty that prevents you from making long-term plans about your research, about your research trajectory, about the people that you might want to work with, et cetera. And what we want to ask here is, well, is this all worth it? And this calculus of whether or not it's worth it, how has that been affected by these falling pay lines, going from 50% in the 60s and 70s down to often single digits now? And then, of course, we can also ask, well, is there a better way to do things? And so what we want to really do in this paper is simply try to look at the balance between a couple of different possibilities. All the science that's made possible by doing grant funding. So obviously grant funding allows us to do all these things we couldn't otherwise do. And this is all the science that doesn't get done, on the other hand, right? Because we're too busy writing grants. And we want to kind of look at, well, what is the relative weight of those things, and is this do we like the way the balance hangs, if you will? So in order to do that, we're going to draw on a branch of game theory known as contest theory. I'm not going to make this talk very technical, but I just wanted you to see that this is kind of a formally definable area within game theory. The basic idea with contest theory is you have a set of agents, 1 through n, that have possible actions or moves they can take. And these typically involve doing something, some kind of behavior in a contest setting. There are costs to the actors of making particular moves, and there are prizes that get awarded to certain actors. And then you've got what we call a contest success function that says that maps from the move you make, from the vector of moves that everyone makes, to a probability vector across the possible ways that the prizes are assigned. And this turns out to be a very interesting and important area of game theory and economics, partly because you can use it to apply to, you can make connections with things like auctions and so forth, and partly because prizes themselves have really taken off in a big way as ways of motivating work. So, one of the really classic ones was the Netflix prize, where whoever could come up with a ranking algorithm that could top some mark won $1 million from Netflix. And meanwhile, Netflix got $50 million of free work from the top universities in the country. And that was very efficient. It was so efficient, in fact, that now there are many outfits that basically implement this process for you. So people use Kaggle. You offer a prize for solving a data science problem. People can come and try to solve the data science problem for your company, and then teams work on this thing, and whoever gets an adequate solution or the best solution or whatever then gets some prize you've put up. Top coder is another one. And in fact, and prizes, of course, go way back. When I was a kid, you used to win a bicycle if you sold the most newspaper subscription, right? And so, in Netflix prize, they want the best solution. With the newspaper subscription, they just want all these kids out there, pounding the pavement. And so sometimes you care about getting the best solution. Sometimes you care about the total effort invested. And more, I think this is actually coming into, the way that people are sort of, running their companies. For example, if you have a bunch of lazy white men in suits, this company here will help you design contests within your own firm to motivate them. Okay. Contests. So all of this we're thinking about in the framework of what we call principal agent theory. So, and this is again, coming out of game theory. The idea is that it's a sort of part of game theory where you actually think about the game of designing the game you're going to have people play. So the idea is that principal, who might be the company that's involved or NSF or whatever, gets to design the rules of the game, and they try to design the rules of the game so that the agents, the individual actors, the people entering the contests, the scientists, do what the company wants them to, or do a socially beneficial thing, or whatever the case may be. The idea with principal agent framework is you're trying to figure out, you've got some goals as a principal, and you want to choose the rules of the game so the agents do what you want them to. And this is typically done under information asymmetry. The agents have private information that you don't have, and that's what makes the whole thing kind of interesting. In the kind of typical contest model, we have a situation that looks sort of like this. We've got a principal that offers prizes. That might be Kaggle or Top Coder or something like that. And then we have these agents, and what the agents do is they provide work in exchange. So the prize creates the incentives for the agents to do this work. They do all the work, and then as a sort of a byproduct, which Kaggle or Top Coder or whatever, you don't really care about very much, but as a byproduct, you do figure out who's good at doing the kind of work that you're interested in. So Netflix wanted an algorithm. It wasn't a personnel hunt, but they did learn what universities had people that were good at designing Netflix-style algorithms. So they get this information. So that's your information asymmetry, right? Is that the researchers may know something about their ability. When it starts out, of course, the people offering the prizes don't. But in this case, they don't really want that. They just want to get the work done. NIH and NSF and other funding agencies flip the logic here. What they do, they offer prizes, and the whole point of offering the prizes is to reveal your type. Who's got the best research ideas? Or who's got the best, product of the quality of the idea plus the, ability of the person in the team they've assembled around them and so on. And so in order to do that, they of course ask us to do this largely useless work of preparing these grant proposals that 3 people at most are going to read on an airplane, and that nobody, and that not in any other way going to contribute to scientific progress as a first approximation. We can talk about how actually it might be useful to write grants and it's fun and we get our best ideas, but I mean, okay. So what I want to do is, so that's what these guys do. And so they get this reveal type, and then what they do learn, of course, is who's best at this. I'm concerned that flipping that contest logic can be a very, very expensive way to get a very small amount of information. And so I want to develop mathematical models to look at that, and that's what Kevin and I have done. And I'll show you kind of how that story goes, just kind of at least through the logic. Of course, there's a paper, and it's kind of all worked out analytically, except that things have to be done numerically and so on. But you can, I'll try to tell you how the story goes. So you've got our faculty member. I've got a research idea, and I've got some idea of how good it is. The faculty member has private information. The faculty member says, this is a really good idea, or gosh, I really don't have a good idea, but I need to submit something. Another faculty member says, it's thinking, well, gosh, how much effort should I put into writing a proposal? It's pain, it's not very fun, and you could be doing other useful things. Well, the thing is, of course, stronger proposals, ones that you put more effort into, are more likely to be funded. So the more effort you put into a proposal, the more likely it is to be funded, but of course you're wasting that effort. At least, and this is kind of the saving grace or some of the logic that NSF and NIH hope is true, is that it takes less effort to write a strong proposal for a good idea than it does to write a strong proposal for a weak one. So if you have a good idea, you can maybe not spend an enormous amount of time just dressing it up in all kinds of fancy clothes. You can write down the idea and say, this is my idea and this is why. But if you've got not a good idea, then the amount of grantsmanship involved and the amount of time involved may be enormous if you can even get to the level of writing a strong proposal at all. So we set up a little model where an idea has a scientific value, and that's sort of encompassing the properties of the idea and the properties of the researcher. And then the researcher writes a proposal of strength X. So these are just both scalars, right? So research says, how good of a proposal am I going to write? And then there's sort of a cost function. How much does it cost to write a proposal of strength X? Well, for an idea of value V, well, it's this cost of Vx. And to keep things analytically tractable, we have this product of G of the idea value times H of the proposal strength, where the cost of writing something is decreasing in the quality of the idea and increasing in the strength of the proposal that you end up writing. So that's the kind of fundamental model. And then because our reviewers were taking things very literally and wanted to annoy theorists, they said, look, we like writing grants, and a fraction of the effort K is recaptured. Okay, fine. So we put in this parameter that's not actually going to do anything in the models, but it made our referees happy. And so set that to whatever you like. I mean, none of the comparative statics are going to change. And so then you have a grant panel, and the grant panel is more likely to fund a strong grant than a weak one. And so the idea is it chooses to fund a proposal of strength X with some probability eta, where eta is where the derivative is increasing in X. So believe it or not, the grant panels are supposedly more likely to fund the stronger proposals. So now that leaves a decision problem for the investigator. The investigator says, okay, this is what she was asking earlier. How strong of a proposal should I write? And of course, what she wants to do is maximize the benefit of getting funded times the chance of funding. And we say the benefit is equal to the scientific value of the proposal. This is, of course, your chance of getting funded, minus the cost of writing the proposal, discounted by this recovery of the time that you wasted writing the proposal, but you really had great ideas and made good friends and all of that. So how strong of a proposal should I write? Well, that's going to depend, right? It's the difference between a cost term and a benefit term. And so if you have a benefit term and a cost term like this, then you're just going to maximize this difference here. Now, the kind of thing that makes all of this work is that, remember, it's cheaper to write a strong proposal for a better idea. So if you have a really good idea, you can write a pretty strong proposal relatively cheaply. If you have a really stupid idea, it takes enormous amount of work to write even a decent proposal. And so what ends up happening, right, is that the optimum that's sort of just setting the derivatives equal or maximizing the difference between these curves. You have the guy with the best idea writes the best proposal, and middle idea, middle proposal, and worst idea, worst proposal. And if this is looking a little bit familiar to the biologists or economists in the audience, this is essentially the logic of screening games and signaling games. So in Jahavi's handicap principle, the peacock's got to figure out how to make a tail to make, and it's costly to make a tail, and it's more costly if you're a lame, disease-ridden peacock than if you're a healthy one. Or in Spence's job market signaling game, it's this kind of similar story about screening game where you decide how much education to get, where it's more costly to get education if you're the type of worker that they don't want to hire, and so on and so forth. So it's a sort of familiar logic to game theorists. So the one twist on that is that we've got this probability of getting funded, eta. Where does that come from? Well, of course, just like those other games I showed you, it comes from who the other players are and what they choose to do. But in our case, it also comes from how accurate the panels are at assessing quality. And we know that's variable matter. But we need some kind of distribution to capture this process by which the panels, read your proposal that's, maybe actually a 82nd percentile, or lower numbers are better. Let's say you've got an 18 percentile proposal and they screw up and say it's a 6, and then you end up getting funded, and it's all good. So what does that look like? So we use these class of probability distributions known as copulas, and these are just probability distributions with joint probability distributions, bivariate joint probability distributions with uniform marginals. And so a copula tells you the joint distribution of the actual quantile and the assessed quantile. So the actual quantiles have to be uniform, the assessed quantiles have to be uniform, and so that means that distribution has to be a copula. And there are various kinds of copulas that we can look at and analyze their properties and how they influence this game and so on. I'm going to just kind of take you through one mostly for our purposes. But what this is really showing is in this particular case, they're pretty accurate at discerning the relative ranks of quite good proposals, and then the accuracy kind of fades off as the quantile falls. So back to this question: how strong of a proposal should I write? Well, that depends on the pay line, as well as because this benefit function depends on the pay line. Via this function eta, this probability of getting funded, and we can use some elegant results that have been done in contest theory to actually compute the optimal bid function here, and that says what's the analytic solution for what this guy ought to do in this situation. And so how good should the proposal be? Well, for one kind of just reasonable fun parameter set, if the pay line is 15%, then the better the idea, the better the proposal you try to write. If the pay line is 40%, then for a proposal of a given quality, you actually, our idea of a given quality, sorry, actually, I've reversed my axes here, thinking economist style. Sorry, if you have an idea with a high scientific value, at the 15% pay line, you write a proposal of some quality. Here, strength. If you're at the 40th, and that increases, so the better the scientific value, the stronger the proposal you write, unsurprisingly. If the pay line is higher, so if you're funding 40% of the grants, now you actually don't write quite as good of a proposal, and it's because you don't have the intense competition among the very best people to try to get funding. So now you're just trying to not look like a wingnut, and then you're going to get funded. That's how I'm told these things used to go. So that's the decision problem from the player's side. The funders have to figure out what they want to do, and this is where we bring in the principal and say, what is it the principal wants to do? The principal wants to think about how efficiently their money generates a scientific surplus. So they might want to know something like, what's the return per dollar? How much value do they get? And that could be in papers written or whatever their currency is, citations, whatever, per dollar invested. I think that's the wrong thing to look at, because what you want to think about also is the cost of running the competition in the first place in terms of this lost scientific output. So I think if you want to actually properly measure ROI, you need to look at the value generated minus the cost in terms of time lost to actually doing science, per cost. And so that's a different sort of a way to do that, and that gives us a net gain per dollar invested that we can think about. So what does this ROI look like? Well, the ROI might look something like this. For a so if you have a very good idea, then you're going to have a reasonably good ROI for if you're at a 15% pay line, but you will have competed a lot to get it, so you've wasted a lot of time. If the pay line's 40%, you just wrote that thing up and sent it off in a weekend. You've wasted a lot less time, and so you've got a much higher ROI because you're not subtracting this business out. Of course, obviously, as the value drops off, the optimal behaviors change and the whole story changes. But we get a kind of picture like this where we see essentially this lost value. We used to have these really high ROIs, for good proposals back when the pay line was 40%, and now at 15%, maybe not so much. Okay, so what we can show in general about the model is that as the pay lines drop, the average return to the investigator decreases. The average scientific value of a funded proposal increases, of course, because you're funding fewer and fewer, so the ones you do fund are better on average. And eventually, the total scientific ROI decreases. So there's a, if the pay line gets too low, then you're going to be reducing the ROI relative to what you could be getting. So that's the kind of first pass story here. It gets worse. So grants aren't all about the money. As you all know who have to play this game in your departments, grants are crucial for hiring. They're crucial for tenure. They're crucial for space and power. They're crucial for promotion, salary, status in the department, everything else. In 1968, I'm told scientists got grants in order to do research. 2018, when we wrote the paper, scientists do research in order to get grants. The tail is wagging the dog because of all of the desiderata that come along with it. And so, we can, of course, incorporate this into the model fairly straightforwardly. Now we imagine that there's something that's useless to society overall, but is private value to the scientist. I might get tenure, I might get a bigger office, whatever. And so we have this private value term here that the funder doesn't care about. The funder doesn't care whether you get tenure or not. It doesn't advance science. It's just something you want, or a bigger salary or whatever. So there's this private benefit term, and then there's the old public benefit. So all we've done is added that term right there. So what happens? It's a train wreck. So here's the private benefit. So the mean ROI, if there's none of these private benefits, we've already seen curves that look like this. It's kind of going up as the pay line goes up. But look what happens once you add just a small private benefit. Now people are willing to work so hard on grants that their net productivity drops. They're willing to tip the balance in the wrong direction. They spend more time writing grants than the benefits they get from the money that comes out of it. And for low pay lines, the ROI is negative. So the funding agency is actually harming the field. And that's why there was burning money on the first slide. I don't think this is really true because of some complications not in the model. But if you're in this zone, the best thing the funding agency could, well, not the best thing, a thing the funding agency could do to improve circumstances would be to put the money in a big pile and burn it. As long as everyone knows that they did it. So, so this is like, I think what you're seeing is this move of flipping the, going from, using a contest to get work done and then learning who's good as a byproduct, to using contests to learn who's good and having useless work done as a byproduct. That's fraught with danger, especially as these pay lines are getting low. And so that's kind of a major concern. So then the question is, well, what do we do about it? And there's a number of possibilities. I don't have a definitive answer, but I want to just show you a couple of possibilities briefly. One is to think about lotteries. So there's been increasingly discussion about using lotteries in giving away scientific grants. And in fact, not only are there editorials and things, this is Ferric Frang and Arturo Casadevall who's been really heavily pushing this, but we also have actually some experiments going on with lotteries. The Volkswagen Foundation, for example, is doing a grant where they're giving the funds away by a lottery, or rather by a partial lottery. So what's a partial lottery? The system that we have in mind works kind of like this. Researchers submit their proposals as before, they're scored as before. The top L% of applicants don't get a grant, but they do get a lottery ticket. And then the bottom, 1 minus L or 100 minus L%, just are saying, "No, your proposal was garbage. We're not going to fund that." But among the ones that are reasonable, you possibly you get a ticket for possibly actually getting the grant that you asked for. And we're going to call L the lottery line. So there are a bunch of possible arguments for why lotteries are good. Most of the Feng and Casadevall arguments are things like this. Lotteries may reduce bias and increase diversity in the funded pool. They reduce nepotism, where you give it to your friends or students or whatever that. They may fund more high-risk research. This is, I think, very interesting to think about. This is something we can think about a lot this summer. Funding agencies always complain that it's hard to fund high-risk research. Then they go and do something stupid like this. This is really amazing. So here the ERC is bragging about the success of its high-risk research grants, because 79% of them achieved major scientific advances, and 99% made appreciable scientific contributions. So, I mean, great, but it's not high risk. They obviously failed in what they were trying to do there. So perhaps lotteries would allow you to better fund high risk research. In addition to those, they may reduce peer review effort. If all I have to do is sort these grants into essentially two piles, that may be substantially easier than doing a carefully ranked score of the 7 best grants out of 100 that we received in my panel. They make underfunding transparent. It's not necessarily clear to Congress and other stakeholders how bad the situation is. But if we say, yeah, the situation's so bad that of the proposals we really wanted to fund, we could only fund 20%. That could be a benefit. The inter-rater reliability is very low when people do studies. NSF has run panels, has had a consulting firm rerun the panels to try to measure, to measure two things. How much do the reviewers agree, and if you do the whole process over again, if you replicate the process, essentially, do you get the same answer? And the answer is not remotely. Though you may do better at sorting the good stuff from the bad stuff, but and often there's one grant that everyone agrees is very good, but then there seems to be a lot of noise in the next few choices. And studies have also shown that grant reviewers' ability to predict the work that's going to be scientifically influential is quite poor. So these are all problems and all reasons that people are suggesting lotteries. We suggest one more, which is that lotteries reduce the effort in preparing proposals, and that turns out to be really, really important to recapturing that lost ROI. And so we're able to prove a theorem or a proposition. I wouldn't glorify it with the word theorem, but you can show that in a lottery, the return to the investigator and also the return to the community or the return to the funding agency are set by the lottery line, and they're independent of the actual pay line. So the idea is if you have, we've already seen, as the pay line goes up, the ROI increases. The same thing happens for the lottery line. And in fact, it's the same curve. If I want to get a higher ROI, instead of, and I've only, suppose I can fund 10% of my investigators, I could run a lottery with a lottery line of 50%, give everybody a 1 in 5 ticket, and then, the theory says that you'll be getting this higher ROI because you'll have more people competing who have to compete less hard for a less valuable prize. And so the idea is that then people aren't going to kill themselves, trying to eke the last little bit of grantsmanship out because they know that they've got to beat the 7 Hughes investigators that are applying for the same grant or whatever the story is. In other words, we can capture the efficiency benefits of a high pay line by replacing a sure payout with a lottery. And then this helps a lot because it also reduces the value of the grant for assessment purposes, for all of those private benefits. If I say, oh yeah, I didn't get the lottery, but I made the cut, and I say, yeah, well, so did half of the people that applied. I'm not that impressed. Your dean can't really make decisions on that the same way they can if you say, well, consistently in that top 10% and so on. So these are some possible advantages of a lottery system. There's some disadvantages as well. Lotteries may be politically untenable. It may be really upsetting to Congress and others who aren't necessarily so sharp on some of these econ arguments to be told that I'm deliberately funding the proposals that my panel doesn't think are the best. I'm funding number 1 and number 6 and number 19 instead of 1, 2, and 3. That just may be really hard to do. There's another thing that we need to work through in some detail, and it's going to require careful modeling and thinking about this, is that switching to lotteries may drive investigators to prepare more grants. And some of that's just going to depend on how many possible targets they are. If you're a paleontologist and you're with NSF, I mean, you can go to the paleontology section. That's it. You're not going to go and start, spamming the biochemists or something. It's just not going to work. But there may be situations where people would increase the number of grants prepared, and we want to make sure that there aren't unintended consequences that would come from doing a lottery. Okay, so I've got just a few seconds. I'll just propose one other way you could do this. It's got some huge equity problems that I think we have to also think very carefully about solving. But if we look at this kind of logical diagram that we had, we had principals that were asking researchers or asking teams to provide work, and then they were accidentally learning something about type. And what was really nice about that was then that work was actually that they wanted was actually getting done, and then we were reversing that here with the grant system. We could move into this schema by rewarding people for doing the work that we actually want done instead of for writing a grant proposal that nobody wants. And so that would be one possible way to capture a lot of the efficiency benefits back, would be to make the contest about doing what people want. Now, the problem with this, obviously, is that that's going to tend to reward people who are in the system and create a bunch of these other kinds of equity issues that have to be thought through very carefully. Nevertheless, there could be substantial benefits if we're going to do all these contests to making sure that the byproduct isn't useless. So I think that's something that deserves thought. There's concern about, well, what are the program officers going to do? Well, one thing they could do is they could go out and scout, like many of the foundation program officers do. Figure out who's got interesting ideas. Ask people at meetings, who are the young people that have these, that have got a great system that I haven't heard about yet, and find that out, and then set up a system where they were coming closer to this notion of rewarding people for having good ideas or doing good work, or in general doing something that somebody actually wants done. So to conclude, what does it tell us? It's kind of a bad idea to use a mostly useless contest as a screening mechanism. That's turns out to be pretty inefficient for the kinds of systems we think about. When there are private benefits to grants that benefit the investigator, but not the, like getting tenure, it makes the problem even worse. And some funding bodies could, in principle, be net negatives for science. And so, we can show that mathematically why a partial lottery might help. And I think more generally, as we're starting to think about these institutions and norms, coming back to what I was talking about at the start, it's going to be useful as we think about grants in particular. These fundamentally are contests. And there's a rich and powerful body of theory there, which I've only kind of dipped my toes into within economics, that we could be looking toward, both within mechanism design and in contest theory. And I think that if we could do a much better job of rationally designing our institutions that ultimately take us all the way through to the knowledge we end up with. So thank you all very much.
Hi, I'm Sydney Wood. I'm from UC Davis. I'm in quantitative and computational psychology. Mm-hmm. And I was wondering if you could maybe give me some insight. I'm really excited to read this model in really intense detail, honestly. And I was wondering if you could tell me what some of the differences are between your mathematical model and the agent-based model that Paul made on open science and modified lotteries.
Right. I think with Paul is not, and Paul is here, so he should just jump in and tell me what actually is true rather than me trying to describe his model from the preprint I read of it. But I think one of the fundamental differences is Paul here to speak up? Anyway, one of the someone should throw him a microphone if he is. One of the fundamental differences I think is in aim. I mean, Paul was really interested in the way that lotteries would actually encourage better behavior than is encouraged in his natural selection of bad science paper. Mm-hmm. Whereas we were really interested in focusing on efficiency costs. Okay. Is that fair, Paul?
Yeah, it is.
Okay, thank you.
No, I think the models are very complementary, and they say different things and look at different questions. And your model is much exactly as you said about efficiency, and my model is about reproducibility and
Right,
sort
so
of.
what Paul has done is, of course, now my slides have gone away, but he's added one more benefit to lotteries. I had this slide with the benefits to lotteries, and Paul's added one more, which is that it may incentivize less bad behavior than the current system.
Awesome.
Thank you.
you.
Hey, Karl.
Yeah.
Great talk as always. Dashun Wang from Northwestern. So I was very refreshing to go through some math, and I really just have technical questions. So I was wondering maybe two factors you must thought about. So I want hopefully you can also elaborate a little more
Sure.
how this may affect the results. One is individual heterogeneity, because the average chance of getting a grant is 20%, but individually it's very different. The George Church of the world versus other people, they are very different.
That comes right into our V parameter. So our V parameter, or the value of an idea, I was saying encompasses both the sort of the value of the idea and the political capital of the person who has it, right? So there are
Right.
people who seem to be quite good at getting grants for quite bad ideas, and
That's what I
they carry high V's in with them, I think.
So the high V people will also have a much higher chance to succeed.
They do, and that's that
the
could
model?
be a serious problem.
Is that in the
equity.
model, or
What's that?
is that in the model? Like,
Yeah, that's what V does. I mean, V influences your cost of writing a grant at a particular level. So if I'm very, very well-known scientist, then a grant simply having my name on it bumps it from a 2 to a 5 before I've even put words on the page. It's like some of these famous old grant proposals that you've seen from 80 years ago, where someone will write to a funding agency and say, yes, 100,000 pounds ought to cover it, and that's sort of the whole thing. So sure, I mean that the person with that kind of personal capital can write a relatively competitive grant quite cheaply simply by signing it.
But in the lottery system, then that advantage disappeared, and everybody is equal footing. Is my understanding correct?
What the lottery system is going to do, I mean, it's still going to allow those people to write stronger grants with less effort than anybody else. But what may not be possible is if the money keeps going to the same 5 top people out of some panel, and then we go from a 10% pay line to a 50% lottery line, now only one of the 5 is going to get a grant on average, even though they all have that level of political capital. You could see that as a good thing or as a bad thing, and Feng and Casadevall see it as a good thing, and I think you can argue in all sorts of directions about that.
I see. And one more.
Can we do one question and then
Yeah, so Malcolm MacLeod, a neurologist, neuroscientist, and failed applicant for more grants than I care to remember. A couple of things. First of all, did you account for the cost to the community of sitting on the other side of the fence in assessing the grants?
No, we didn't even put that in because we wanted to. I mean, it's a model that we just wanted to focus on one element of that. Yeah. If you put the cost of the community in, obviously it becomes even worse, becomes even more inefficient. You can, of course, write down pretty good financial cost estimates and pretty good time estimates for the amount of time that goes into the, say, NIH panel review process, and you can put all of that in. It's not necessarily obvious that those numbers are easily commensurate with the numbers that you get in terms of, science that could have been done. If it takes me 80 hours to prepare, 160 hours to prepare a grant, then it's not quite clear how that trades off against, hotel bills in Bethesda.
And then the other thing is that you teased us with a lottery payoff line that at 50% was still heading north. So does that reach a maximum, or does it carry on to 100%?
Oh, great. Thank you for asking that. Yeah, it's a great question. It does reach a maximum, and it does start to slide. And the reason is because if you take the lottery line too far, you're going to be funding some of the really not good proposals. I mean, these things are all dependent on the distribution of the proposals that are in there. But if you go to 100%, then you've got essentially no preparation costs. You just check a box. But on the other hand, you're funding the grants that anybody could see. And when you sit on one of these panels, there's a third of the grants that you just are badly mistargeted or misthought or whatever. Thank you.
Yeah, Richard Wynn from Res Cognito.
Yeah.
I'm not an academic, so please be tolerant with this question. But the previous speaker mentioned that we should look not just at the outcomes, but what people did, not just.
Right.
And how is that taken into account in this situation?
In the grant.
Is there a part of the grant process that says, yeah, the outcome, if it works out, will be great, but this researcher doesn't use practices which will allow it to be reproducible or tracked or...
Great question. There is definitely a place for that. When you write a grant, you're going to typically write out the methods, and more and more you do things like write out data management plans and things like that, where that some of this could come over to make sure that everything's being retained to make things reproducible on down. Kevin and I just had to write one for the future failed grant that we submitted, so those places are places that comes in. And as the culture takes off, where we start to see this as very important, we say, look, I don't want to see any more work of that, or I don't want to see so much more work of that sort unless it's pre-registered, because I'm just really worried about garden of forking paths issues or whatever. Then that can become a serious evaluation criterion that the grant panel would use. So I think those things are fairly easily taken into account in the funding process as soon as they become important to the community. And what we have to do is make sure they're important to the community.
David Allison, Indiana University, Bloomington. First of all, terrific talk. I really enjoyed it. As someone who spent much too much time in his life writing grant proposals, it resonates.
Yeah.
I've done analyses of a leading school of public health, in which I'm leading me top 20 in terms of NIH funding, in which about the average funding rate on a first submission is about 17%.
Yeah. Mm-hmm.
And the top hitters, 90th percentile after you apply some reasonable shrinkage, is about only 34%. Double
Right.
that means the best hitters strike out 2/3 of the time, just like in Major League Baseball.
Wow. Yeah.
So,
And they don't get that kind of money.
no. So I'm completely on board with much of what you say and the problem, and I think it does need to be addressed. We do devote too much resources to that. You've gone to a very extreme alternative proposal, at least in my view, which as an intellectual foil, I think is superb.
Yeah.
To suggest, hey, maybe what we're doing is no better and perhaps even worse than a lottery.
Yeah.
But you've left out a lot of the space of other possibilities.
Yes,
and
that's
I
true.
just think that's important to recognize that there's an infinite range of other possibilities between the status quo and a lottery that would perhaps promote greater creativity, reduce the time burned in this activity, such as, two-stage proposals, such
Right.
as eliminating deadlines as NSF and Wellcome Trust did at
This
times,
was brilliant.
which reduced proposals and so on. So
The true stage proposals didn't work very well. People ended up putting as much time into the first stage as they were into the second stage, and then they had a lottery ticket that they had to write another grant if they wanted to cash in. These are exactly the kinds of things that we need. We need to have people talking about, what are the different alternatives? How could we do this? And I do think that there is a rich literature in contest theory and principal agent modeling and so forth that could really help us out there, because it's not a problem that nobody's ever looked at. It's a problem that very good people have spent a lot of time looking at.
thank you.
So I'll skip my turn. because
Sorry,
I think the
I've got to
gentleman
interrupt
the
on
other
this.
side is-
So, I'm sorry, I'm going to interrupt. We are stuck on time on this, but I want to take prerogative to have the Assistant Director of NSF ask the last question here. So, sorry for that.
Yeah, so that's that.
Yeah. Oh yeah. Sure. I can't leave out the back door.
No, it's double trauma game theorist too. So, this is a really interesting talk. So we're always looking to improve things, but I just have a question about
Sure.
a realistic alternative.
Yeah.
So, the things that we fund, there are people on the other side of the science at NIH and NSF. There are real people, there are real problems, and for a lot of them, the work that we do, it helps the entrepreneurs, it empowers the communities, and for millions of people we'll never meet, we are their last best hope.
Yes.
Right? And so funds are limited, and so is attention. Like there's an infinite number of things we could study, but funds and attention are limited. And so this really matters. So
It's the best argument I've ever heard against a lottery, by the way.
Well,
is that, because I always think about basic science. And if you say
Yeah.
you really want, this person's last best hope to be
Yeah.
given by a lottery, I
yeah.
don't know.
So now, there's just two angles to this in terms of thinking of the value of the peer review process, right? And so one is, so Andy Gelman told this great story about like when we get the reviews back and we all have the same reaction, right? Newsflash, we're the reviewers.
Right.
Right? So, you have this emotional reaction, like, I didn't get funded, I didn't get the thing, like, and it totally sucks for a while. And then you put it aside, but like, haven't we all, I don't know about you, I mean, I feel like me and everybody I know, we've learned from that process, right? I mean, I think about changes. I mean, yeah, a lot of it was nonsense, a lot of it was people sort of, telling me to follow their path, but some of it was really interesting. So I think that's, thinking about the value of that, because if we have lotteries, where does that come from? And it could come from other places. The other thing is authority generation. So if you think about, everybody thinks they're a genius, right? Great. With some probability that conjecture is true. But one of the things the process helps us with, if we have any confidence in one another, because we're the reviewers, we didn't do AI yet on review processes. It's our judgment. So I just think about those two sources of value. But now that's not here's the game theory thing.
Cool.
So suppose we move to the part where a lottery has positive, relatively positive returns on investment.
Yeah.
In equilibrium, the best response should be no proposals. Right?
Should be, what's that, please?
The best response in equilibrium should be actually no proposals, like 0 time put in a proposal, because it's going to be done by a lottery. So what I should do is I should draw a big X on a piece of paper and hand it in and say, this is my proposal.
Well, if it's a complete lottery, but
there's no review process. Well, I'm just going with the math in your model.
Right. So in the limiting case of a complete lottery, that's completely right.
Right. And so at that point, then we shouldn't even have proposals, because my best response beyond that would be, let's say I could put like 3 words in it, then what I'm maximizing is I'm going to send in as many proposals as possible, but then that kills the system too. So now the basis of the lottery shouldn't be on a proposal at all. It should be just on a people. Like we're just going to give money to you guys, to a person who is eligible in a category, which again is fine, except when we think about the people on the other side of the research. And then,
I think that's really interesting comment. And by the way, that actual proposal where everyone checks a box.
Yeah.
I mean, people are talking about that, for better or for worse. You probably know this very well, but there are people that are for the audience. People are talking about doing exactly that. And there are also kind of strange ways of deciding who's eligible. Are you at an R1 institution or something? But there's actually. I mean, it's not like just. I mean, it's kind of a crazy suggestion, but people are at least talking about that crazy suggestion. So it's worth pointing out that yes, that's what will happen there, and if that's what you want to happen, then you need to take the consequences. And one of the consequences is as you do that ROI is going to plummet. Yeah. And that's even before. I mean, that's holding the set of participants constant. If you allow participants to flood in now as you do this, now you get a flood of people that are just complete jokers that come flooding in and checking the box. And the whole thing, melts down entirely. So I think that's a very good point.
Well, it's a good conversation. Much love to you, man.
Yeah, thank you very much.